Okay, so this is lesson 6.4 over logarithmic functions. This is my second time recording this because the first time it did not convert. So I'll try not to fly through this out of impatience and upsetness that I'm doing this again. All right, I'm going to go ahead and share my document camera. So this first one, so what do I want to use? I have the papers I was talking about previously too on that. It has all the rules and stuff on it. So we're on 6.4, the logarithmic, and it has the properties of a logarithmic function, the domain, and then 6.4 continued here. And we're going to use this one near the end of our lesson and this one right here a lot. So I went ahead and wrote these two down on a sticky note right here. And that's what we're going to be using to get through this. So on all of these, when you get them, I want you to figure out what your AX and Y are. So AX, Y every time, just to help you keep it situated. If you don't need to do it, don't. But if you want to be sure you're keeping everything organized, I'd highly recommend it. So our A in this log form is 3, and our X is 9. So then we're going to rewrite it because we don't have a Y, we don't have an equal sign. So we have 9 equals 3Y. What is Y equal for this to be true? And that would be 2 because 3 squared is 9. For some reason on my homework set, but the other classes set that I did this on, because I always go through them and practice before I do this, they're not the same, but there's a couple of them that are the same. So this one right now, we're going to go ahead and do that because these two are the same problem. And it even find the exact value without using it. Okay, so here we go. If we have one that has a base of 4 or a base of anything and the main number is 1, it's going to be 0, but we're going to do this real quick. So A, X, Y, our A is 4, our X is 1, we don't know why. So you have 4 I'm doing something wrong. 4 equals 4 to the Y power equals 1. Because 4 is A, Y, 1. So to get this 1, it's the 0 exponent, because the 0 exponent rule is anything raised to the 0 power is 1. So 4 to the 0 power equals 1. Anything raised to the 0 power equals 1. So this one's 0. A, X, Y. A is 2, X is 1/8. So we have 1/8 equals 2Y. So we need to get our bases the same. So I need this 8 to be a base of 2, and I can do that because 2 to the 3rd power would be 8, and then for it to be under 1, it means it's a -3. So I have 2 to the -3rd power equals 2Y, and then since our bases are the same, Y equals -3. So AX, our A is 1/4. Our X is 1024. So we have 1024 equals 1/4 Y. I need 1024 to look like 1/4. So we need to see how many times 4 goes into 1024. So let's do divided by 4. Once, twice, 3 times, 4 times. So it's 4 times, and then we'd have that negative, and the negative is what's going to put it on the bottom. So let's go ahead and check that. So we have 1/4 raised to the -4. So let's try. If we divided 4 by 4 again, can I get to it? -5. So we're going to write 1/4 to the -5th power equals 1/4 y. The bases are the same, so y equals -5. Find the exact value. We have 2 square root of 2, so we have a and x. Our a is 2, our x is square root of 2. So we have square root of 2 equals 2 to the y power. A square root is, remember, if you had me, the top of an exponent is the power and the bottom is the root if it's an exponent. So this is 2 to the 1/2. 2 to the y, because this would be a square root, power, root. So y equals 1/2. So a and x, a equals 6, x equals 36. So we have 36 equals, this is square root of 6, equals square root of 6y. Now, you have to remember on this one, if I squared the square root, it would be a normal 6, and then I'd have to square 6 to get 36. So this is 4, because to get rid of the square root, we have to multiply it by 2. And then to square 6, we'd have to square it. Oh, tongue-tied. So what am I trying to say to you? Because that square root times the square root would be 6. Square root times the square root would be 6. 6 times 6 is 36. So we have 4 of these. So y equals 4. Because we have 1, 2, 3, 4. Okay. These are nice. So we're going to change these now. We've been using this and going to this. Now we're going to take our AXY and go to our log form. So AXY, A is 4, X is 16, and Y is 2. So we have 2 equals our log with a base of 4, and X is 16. AXY, A is A, X is 5.8, and Y is 4. So 4 equals log of A, which is A, and X is 5.8. They really confuse me when they have an X that is a Y, and that's this one. So we have A, X, and Y. So A equals 4, X is 7.8, and Y is X. Isn't that lovely? So we have X equals log 4, 7.8. All right, on this one, you can use this still, or I'm going to write it down real quick too while I'm talking about it. So we have y equals the natural log of x, and then x equals e to the y. So we really only need x and y on this one, so we can take out a step if we are dealing with natural logs or e, the natural number. So here we go. Let's see. Our x and our y, and we have this form, so it equals 3 and our y is x. So then we have x equals the natural log of 3. So I don't need this one right now, so I'm going to put it over there. So a, x, y, our a is 6, our x is 36, and our y is 2. So, oh, we switched what we're doing. I should tell you that. So we're going from logarithm now to exponential, so the equivalent exponential statement. So our x is 36 equals 6 squared. And write it like that. Don't simplify it. They don't want you to do that. Just write it. A, x, y. Our a is 4. Our x is 1 over 256, and y is negative 4. So we have our x 1 over 256 equals 4 to the negative 4th. A, x, y. Our a is a. Our x is 5, and our y is 2. So 5 equals a squared. That looks like a 5. It's in the way. A, x, y. A is 5. X is 25, and y is 2. So 25 equals 5 squared. Okay, so we're halfway through this for the second time. Although y'all don't know the second time. For the first time. Oh, natural log. I get to use these. So I just need x and y. So my x is 9, and my y is x. This is where it gets confusing. So I always write my ax and y here, and then the numbers they were over here, just to keep it in order, so I'm not like going back and forth. So ax, y, what they equal. So my x is 9 equals e, and my y is x. Wait, on these you're supposed to use your calculator, so calculator. Clear, we have natural log, fraction, because it's 49 over 16, close up parenthesis, and then once you round to the first 3 decimals, so 1.119. On this one, we got to break this into 2 steps, so we have natural log of 77 over 64, and then we're going to divide by 0.06. So 3.082. On this one, be sure you type that fraction bar first. So we're going to have natural log 26 close plus natural log of 13, not 16, over log is right above that. 26 close log of 13. Natural log 26 plus natural log 13, log 26 plus log 13. 2.302. Okay. If y'all don't have calculator, email me and I'll get you set up with the free version from TI of this calculator. And I'd recommend using this one because it's just the easiest to do this fraction stuff on right here. But you can use whichever ones you want. And if you're using TI, I can definitely help you out super easy because I'm a TI person. If it's Casio, I'm going to be doing a lot of Googling too. 2 natural log 2 log 4 log 196 subtract natural log of 14 negative 5.733. Okay, this graph one. I'm going to hop now. New share basic. And I think I've already done it on this once, but I'm going to reset it and we'll do it again. Your screen sharing is paused. Why? New share this. Share. Okay. And this is number 21. And I did this previously on the other one, but we'll go ahead and do it again. Similar question. And we're going to click to enlarge. Now, this is the exponential one, like off the last lesson. So we're going to do exponential tool. Doesn't matter where we click, but they have it now is that we have this natural number for our base, and our base is 3. And then they want us to graph them both. This is the logarithm tool. We're going to use it to graph this logarithm. So click anywhere. It has the natural number as the base. We're going to change it to 3. Save that, check answer. Okay, I'm going to stop this video and start another one because this one takes a good little bit to do in itself. So let's